In this quick video, I'll take you through the process of reconstructing this broken miter saw cover using 3D scanning, reverse engineering and 3D printing, and we're starting right now. Welcome to the Crosslink channel, my name is Daniel and here we cover everything related to 3D printing, 3D scanning and 3D design. Today we're focusing on this broken miter saw cover which we'll 3D scan as our first step. The Revopoint Range scanner is the right scanner for an object of this size. However, we'll need to tackle two issues with this part. It's relatively transparent and quite dark, both factors that aren't ideal for 3D scanning with optical scanners. To overcome these challenges, we'll use scanning spray, specifically AESA Blue, to create a grayish surface texture that's better suited for scanning. Once the scanning spray is applied, I'll scan the part from both sides to capture independent scans, which will be combined during the reconstruction step. With the help of the turntable and the Revopoint Range, the scanning process takes about 5 minutes. Now we have two scan results that can be combined to create a single part for reconstruction. While this might seem sufficient for 3D printing, we need to ensure precision as this is a mechanical part that must fit the machine accurately. In the past, I have 3D printed directly from 3D scans like this lion statue and these other prints, but for this project, we'll collaborate with Satish Kumar, a reverse engineering expert on Fiverr, who will reconstruct a part from our scans. I've also provided him with detailed measurements and annotated pictures of crucial regions. It's essential to use a caliper to accurately measure key distances and part thicknesses, ensuring the best dimensional accuracy. First, Satish aligns the two scans to create a single object as the basis for reconstruction. Next, Satish builds a completely new part around the 3D scan, constantly comparing and overlaying the scan with the new part. The final result looks impressive, but we'll only know if the dimensions are accurate after 3D printing and potential adjustments. Step 3 involves printing the reconstructed part. Since it's too large for my printer's build volume, we'll cut it into two pieces and print them separately. Finding the right orientation and minimizing support material usage can be challenging. I've opted for PETG for stability and switched to normal supports after experiencing failures with 3 supports. But still, printing with standard supports, it worked out somewhat, but this part is still very hard to remove the supports, a lot of support wasted, and the end result isn't that good. And this other part here was printed with 3 support, also not quite successful, a whole part of the thing is missing. So finally I found an orientation that worked and the result was acceptable. With the 2 parts printed, we need to glue them together and attach a separately printed add-on to hold the rubber wheels. Upon comparing measurements with the original part, they appear nearly identical. If needed, the customer can make slight adjustments by drilling holes, sanding, or applying heat to deform the part. We didn't include grill slots in this design to ensure maximum stability during 3D printing. The customer will drill holes for air pressure release themselves if required. After handing over the part to the customer, we'll await feedback for its functionality. As you can see, the process from 3D scanning to reconstruction and 3D printing is quite straightforward. If you lack skills in any step, you can always leverage external experts or services like Fiverr to fill in the gaps. If you enjoyed this video, please hit the like button, and for more content like this, subscribe to the channel. Let me know what topics we should dive into deeper. I'm eager to get your feedback and to answer your questions. I'll catch you in the next video. Bye!